All right, you probably know that there are two types of charge. They are positive and negative. And Ben Franklin is the guy that told us that. So I just want to show you a way that you can prove that there's two types of charge and then talk a little bit about what Ben Franklin did. So what I've done is I've stuck a single piece of tape down to the table here, Scotch tape, and I'm going to label that A. And I'm going to put it on the ring stand so that the non-sticky side is out. Then I'm going to take another piece of tape and I'm going to put that down on the table in the exact same way. And then I'm going to put a piece of tape on top of that tape. And I'm going to label that one B. Okay, then I'm going to pull them both up and then pull them apart. And I'm going to put tape B on this same ring stand. I'm going to get it over here on the side. And you can see here I've got tape A and tape B. So this tape that's just stuck down on the table is just going to be just like tape A. So if you look here, tape A likes tape B, but it doesn't like tape A. So it pulls in tape B and it repels tape A. So that's just one quick way that you can show that there's two types of charge. And the rule for charges is that opposites attract and likes repel. So how did Ben Franklin figure this out? Well, he didn't use Scotch tape, but he had animal fur and a hard rubber rod. So if you take and you rub the animal fur on the rod, he knew that that behavior was different than if you take a piece of silk and you rub that on a piece of glass. The silk and glass has a different force. Let's see if I can get these separated again. The silk and glass likes A and doesn't like B. But the fur with the rubber rod likes B and doesn't like A. So I'm not sure what he used. He probably used something more like this contraption right here, which is called an electroscope. You can see that there's a couple metal leaves in there. And an electroscope detects a charge because if I take a charged object like this rubber rod and I touch the metal, the leaves pick up that charge, and since they're charged like, and like charges repel, they push away from each other. So Ben Franklin said because there was two main categories, he called the silk and glass positive and the animal fur and the rubber rod negative. And he said that those were the two fundamental types of charge, positive and negative, and opposites attract, so positives attract negatives, and likes repel, so positives repel positives, negatives repel negatives. It's a more static electricity demonstration, so there's also two ways to charge things. There's two types of charge, there's two ways to charge. So the first is friction, which is what we were using it for. So you rub electrons, in this case off of the animal fur, onto an insulator. And it needs to be an insulator because when you put them on there, if it's an insulator, that's a material that doesn't let electricity flow. They'll just stay put right where you put them. They don't travel to my body or anything. So I'm rubbing them onto the insulator. You can kind of hear that Rice Krispie sound. And then I will touch this pom-pom, which is like a type of electroscope. It shows me that this was a charged object because when I touch it, it gives the electrons a place to go, and the electrons spread out in those individual tassels of the pom-pom, and it kind of makes it stand up like that. So this is charging by friction. You're rubbing electrons onto an insulator, and then I'm just putting those on that pom-pom. So we could say this is negatively charged. Now Ben Franklin didn't know that it was the electron. No one had discovered the electron yet. In fact, one thing that's really important in static electricity is we know that protons don't move. So when we talk about charges moving, it's electrons that move. But Ben Franklin didn't know that either. So he kind of actually screwed it up. When we first learned about electricity, we always described the direction of current as the flow of positive charge. And so we've actually stuck with that. But here I'm putting electrons onto an insulator. So I'm gonna just let that pom-pom sit over there. And I'm gonna show you the second method of charging, which is called induction. So I have this open house sign, which is made of a material called Corex. It looks like corrugated cardboard, but it's plastic. And I will rub the animal fur on that. And then put the aluminum pan on there, and you can see that I've got a handle. And then I touch the pan, and it shocks me. And now I've made a positive charge, which I can show you that's a positive charge. I'm gonna do it one more time. So you rub the electrons from the fur onto the sign, and then I put this pan on here, and the pan actually becomes polarized at this minute. So what's happening is the electrons in the pan, it's an aluminum pan, so each atom's got 13 electrons, but the electrons that can flow, they're going to go to the surface and try to get away from the sign, and then enter my finger, and they all jump to me. And now what's left in the pan is more positives. So when I touch the pom-pom, I'm actually stealing some of the negatives from the pom-pom, leaving the pom-pom positive. So now I got a negative pom-pom here and a positive pom-pom, so that you can see that they're attracted. You can witness the rare mating ritual of the electrostatic pom-poms. All right, so we're gonna do a quick recap with some notes here of what we've talked about. So there are two types of charge discovered by Ben Franklin, which we said are positive and negative. And Ben Franklin said this is like silicon glass, and this is like fur and plastic. And the two types of charges are because there's particles responsible. So we say the proton is responsible for the positive charge and the electron for the negative charge, which we didn't discover protons until the 1900s, like early 1900s, and electrons were right around the turn of the century. So those are not things that Ben Franklin knew about, but we know that the proton is responsible for the positive charge, the electron is responsible for the negative charge. And since protons are in the nucleus, you're not going to get them out of the nucleus once you do a nuclear reaction. So with electricity, really protons never move. So whenever we describe something, we don't talk about protons flowing or something. There's one thing that we never talk about in the electricity unit, and that is the neutron, because it's neutral. So a lot of people like alliteration, and they think, well, if protons are positive, that neutrons should be negative, and then it would start with the same letter, but they're not. They're neutral, neutron, neutral. So we won't speak of them at all, because neutral things aren't charged, and electricity is about the flow of charge. Electrons are the negative particles. So we then talked about the rule, which is that opposites attract and likes repel. So if you have some positive charge, it's going to repel positive charges. If you have some negative charge, it's going to repel negative charges, and positive and negative charges are going to attract. So that's your basic rule for the forces. It can be both attractive and repulsive with electricity. There are two ways to charge. And they are friction and induction. So friction was just rubbing electrons onto an insulator. So it could be wood, rubber, plastic. Any material that doesn't conduct electricity is an insulator. If it does conduct, it's a conductor. And induction was the last example, and this is usually associated with making a positive charge. So what I took was the open house sign, which is an insulator, and I rubbed a whole bunch of extra electrons onto that. So I'm just gonna put a bunch of little negatives here to show that that's got a lot of extra negatives. Then, this is gonna be enlarged to show texture. I put the open house, or put the aluminum pan on the open house sign. And the aluminum pan is made of aluminum, so it's got 13 protons, 13 electrons for every atom. It's neutral. And it does something called polarization. Polarization is when charges line up. So that's exactly what happens. The charges line up. Meaning that all the negatives in the aluminum are not happy with me because I just put them right next to a very negative sign, and likes repel. So they run to the surface, and the positives stay in the bottom of the pan because they're liking this situation. They're by the negatives. So this is a pan with all of its charges lined up. It's not a charged pan, it's still a neutral pan, but all the charges are lined up. So it's polarized. Then enter my finger. Those negatives would like to get away from this open house sign. And when I put my finger in, I've given them somewhere to go. So if I touch the pan, they will all run via my finger to the ground so that there are no longer as many negatives in the pan. I took a lot of them. Again, it's the negatives that are flowing. But what's left, what I've induced, is a positive charge in the pan. Now, I couldn't directly put positives on the pan. I can't give it some of my protons, but I can take its negatives away and induce a positive charge. So the definition of induction is providing a path, which is what I did with my finger, for electrons to leave. That's the second way to charge. And that's basically your static electricity vocabulary. So we have friction and induction as the two ways to charge. Polarization is when charges line up.